Hi. So, we will be discussing on cloud computing, primarily looking into the cloud security. So, this may be the this series of lectures, the third talk on cloud security. So, in this discussion, we will be basically trying to look at a case study taken from a well known research article. It might so happen that many of you have gone through the article, or if not, it will be good to go through these articles. That is pretty one of the interesting article which shows that where this security in cloud computing varies or how it differ from our generic network or computing security, or where what are the extra things we need to look at when we look at the cloud security per se. So, it may not be possible to go for all deep into the technical details of this research article, but what we will try to give you that a overview of the problem which will help us in understanding that how security matters, even when you are using a standard, secured, trusted, well used public cloud computing platform. Okay. So, one that article we are talking about is came in ACM CCS 2009, and by this the title says that, "Hey you, get off my cloud, exploring information leakage in third party compute clouds." Right. So, what they demand is the first work in cloud cartography. But apart from that, it is interesting to see that what are the different way things will be there. So, it is the our major objective of this particular discussion is to more look into the security aspects of the cloud. It is not on looking into any loophole of a particular cloud provider or security of any particular provider. We try to look at this paper which is done which is there are some practical experiments which may help us in understanding the security aspect of the cloud in a better way. That is our objective. It is not to analyze the work per se, but to take that work as a example case and see that how security it plays an important role in this cloud computing aspect. So, the experiment done in this particular work is this some sort of a so called quote unquote attack launch against a commercially available real cloud like typically Amazon EC2, and what they claim that 40% success in co-residence with the target VM, right. So, if we remember our earlier lectures, what we are telling that one of the major issue is that if you whether we can co-residence a particular what we say attacking VM or a malicious users VM to a target VM. So, that is a very challenging task, because I really do not know how a cloud provider allocates the VM to other things. So, what we have seen in the new risk in cloud, one is that trust and dependence, right. Establishing new trust relationship between the customer and cloud provider, that is important, because I am basically as a customer leveraging all my most of my data, most of my processes on the cloud, and I am somewhat going dependent on that cloud infrastructure. So, customer must trust their cloud provider to respect the privacy of the data and integrity of the computations, right. So, when we look at the security point of view, the customer must trust the cloud provider for the preservation of the privacy of the data and the integrity of the computation. If there is a process, the process is supposed to is performing the way it is supposed to perform. That is one of the objective of this of any customer, right. So, that is expected. Now, the other problem, so that is how much you trust and dependent on the thing. Other thing is the multi tenancy, right. Threats from other customer due to the say they are basically residing on the same VMs and physical records can be transparently shared. So, what is happening that I am that the virtual machine what I have been allocated in the same physical machine some other customers are also allocated. So, what is the chance that there is a path establishment between these two VM, and if there is a malicious VM or this process is running in a malicious VM, what is the chance that my VM or my process is likely to be compromised. So, that is the usual problem of multi-tenancy. When you have multi-tenant data, these are the things which is which becomes a big issue. So, multi-tenancy, as we have discussed earlier, multiplexing VMs of disjoint customers upon the same physical machine. So, your machine is placed in the same server with other customer. Problem, you do not have the control to prevent your instance from being co-resident with the some adversary instant, right. So, if it is a multi-tenant, so this multi-tenancy how it will be deciding, that is at the that is the logic the cloud provider doing. So, from the cloud provider point of view, it's one of the major thing is resource management, right. It has a limited resource or it has a particular resource and it has to manage the thing, so that it optimize the performance of the customer level. So, based on that it basically try to deploy the VMs based on its this analysis of that how resource can be properly managed and maximum performance level can be provided to the respective customer vis-a-vis their service level agreements, right. So, here with this with the multi-tenancy, some of the new risk factor came into picture. One is that slide channel exploitation. That means, cross VM information leakage due to sharing of the physical resource. So, that is another a big challenge, right? Cross VM information leakage, sharing of the physical resource is there. Has the potential to extract RSA and AES secret keys. We do not know whether there is a potential to extract RSA and AES secret keys of this cross channel, all this side channel exploitation. There are vulnerable VM isolation mechanisms like via a vulnerability that allows an escape to the hypervisor, right. So, if there is a vulnerability, so if that can be exploited and this hypervisor to some extent can be compromised. Lack of control, you are sharing the server space, right. So, lack of control who you are sharing with, right. So, you do not have any control that who we are co-residing with, right, or this you are sharing the same purpose. So, these are the new risk which come into play, and the attack model, specifically the attack model which is being also followed in this particular work what we are discussing is that one of the motivation of this attack model is to study the practicality, that whether it is practical of mounting cross VM attacks in existing third party compute cloud. So, if I am having a existing third party compute cloud, is it possible to do to launch some sort of a cross VM attacks, right, if on the things, right. So, what they did, the experiments have been carried out on real IaaS cloud provider like Amazon EC2, and this can be carried out to any type of IaaS provider. So, there are two steps, and these two steps are irrespective whether it is a cloud or network or anything. There is one is placement, adversary arranging to place the malicious VM on the same virtual machine as that of the target customer. This is important. If I want to do a cross some sort of attack or something, first thing I have to do is that whether I can physically place my VM into the same space or the same physical machine or the same server space where the adversary's machine is there. So, that is one important thing, and secondly it is a extraction thing. So, once I am placed, so extract confidential information by side channel attack. So, these are the two type of. So, next is the threat model, like assumption of threat model is that the provider and the infrastructure to be trusted, right. So, what we do when we are doing, one of the basic assumption is the provider and the infrastructure need to be trusted. Do not consider attack that rely on subverting the administrator functions, right. Do not exploit vulnerabilities of the virtual machine monitor or other software, right. So, it will not exploit that hypervisor and other things. So, adversaries non-providers affiliated malicious party. So, adversaries are not provider affiliated, they came as a user or customer. Victims, user running confidentially requiring services of the cloud. So, victims are running some of the operations which needs some basic privacy and confidentiality, is not public operations or public data, and services through the cloud. So, focus on new cloud related capabilities of the attacker and implicitly expanding the attack surface, right. So, we try to see that what are the things and try to see that what type of other attacks. So, there are other threat models consideration, like any customer, the malicious party can run and control many instances of the cloud, right. So, that is another thing. Attacker's instance might be placed on the same physical hardware as the potential victims are. Attacks might manipulate the shared physical resource to learn otherwise confidential information. So, that attacker can basically do some sort of cross VM attacks. So, two type of attacks can take place: attack on some known hosted services or attack on a particular victim services, right. So, one attack is that I know that these are the hosted services, I want to attack on the things, or I want to have particular victim service to be attacked. So, there is more what we say targeted attack. So, in order to do that, so what they propose or what they did is basically need to answer few questions. One is that can one determine where the cloud infrastructure and instance is located, right. So, is it possible to determine that where a particular instance is located, right. Very difficult, not only difficult, something apparently impossible, right. You take a login from Amazon or Azure or Google platform or any other Salesforce or anything, and that is their way of handling the things, like at the back office management or the backbone management things. Question 2, can one easily determine if two instances are co-resident on the same physical machine, right. One is that finding that where the one instance is there, another is that whether it is possible that I can determine that whether these two instances are co-resident, right. Number 3 is that can an adversary launch instances that will be co-resident with the user instances, right. So, other question is that whether the adversary is launch instances, so that you want to co-residence with some targeted instances. And number 4, can an adversary exploit cross VM information leakage one co-resident. So, if it is a co-resident somewhere other, whether there is a possibility that there I can have a cross VM information leakage, right. So, these are what they did the experiment, or what we are trying to get an overview of the whole thing is primarily working on one of the very popular cloud provider, and it follows all possible best practices. Even with that, whether it is possibility is there or not, that is the thing what we are trying to look at. So, if you look at the Amazon EC2 service per se, so it is a scalable pay as you go compute capacity of the cloud. Customer can run different operating system within the virtual machine, 3 degree of freedom, instance type, region and availability. So, when you do select, so there are 3 degree of freedoms. So, you can have instance type, what type of instance, or which region you want to launch, and the availability zone in the things, right. So, 3 computing options instances are available. One is M1 small, M1 medium, 32-bit architecture, M1 large, M1 extra large, and so forth. So, these are the different instances are available, right. So, there are different region available, right, US, EU and Asia. This is the time when what the paper tells, that is what when they came up in 2009. So, region split into availability zone. So, if you look at the in US, it has a east in the east Virginia, west Oregon, and the west another thing is northern Carolina, right. So, similarly infrastructure with separate power and network capacity connectivity, right. So, these are the different physically different located at different places. So, they have not only different power line, that means they are not on the same power backbone. So, that in other sense, that is they are not subject to failure if there is a power failure of one instances, and it is likely their network also is different, right. So, that means the IP block used in one will be different than other and type of things. Customers randomly assign to a physical machine based on their instance, region and availability zones choices. So, customer has this option of choosing taking make a choice of this, and based on that they are given to the different machine. Typically Amazon EC2 service using HP hypervisor, and if you Xen hypervisor, sorry. So, if you look at the Xen hypervisor, so there is a DOM 0, what we say portion, what is the privileged virtual machine which manages guest images, it provisions physical resources, access control rights, configured to route packets in his guest images and reports itself as a hop to the trace route, right. So, it routes the things, and that it is a hop on the thing. So, when an instance is launched, it is assigned to a single physical machine for its lifetime, right. So, the instance particular anything. So, secondly, each instance is assigned internal and external IP address and a domain names. So, that is the philosophy of Amazon. So, external IP address something, internal IP address based on some standard and respective domain name. Within the cloud, both the domain names resolve the internal IP address. So, within the cloud, both the whatever you have seen internal and external are thing. Outside the cloud, external name is mapped to the external IP address. So, when we go to the outside the cloud, then the external name is mapped to the external IP address. Now, if we look at the different aspects or the different queries which we raised, or which the article raised, and try to address those, and those queries. So, query 1 is the cloud cartography. Instant placing is not disclosed by Amazon, but is needed to launch co-residency attack. So, if I want to do some sort of a co-residency attack, then I require the instant to be placed into the victim's things, but the Amazon will definitely not disclose this, and map the EC2 service to understand where the potential targets are located in the cloud, right. So, we need to map, or what they have shown, they have tried to map the EC2 service to understand that where the targets are located in the cloud. So, determine the instance creation parameters needed to attempt establishing co-residence at an adversarial instance. So, it is create a parameter to attempt establishing a co-residence on the thing, and the basic hypothesis, different availability zone and instance types correspond to different IP ranges, right. So, if I have different availability zone and different instance types, it is likely that they are in the different IP ranges. So, whether we are able, whether we can, there is a possibility of exploiting this. So, in order to do that, those who have worked on network security or networking per se, you know that there are different type of network probing tools are available. So, network probes are available, and which are many of them are open source and fairly able to map the thing. So, similarly, here also we require a network probing, identify public servers hosted in EC2 and verify the co-residency. So, open source tools have been used to probe the ports, port 80 and port 43, that is the HTTP and HTTPS secured port, right, or SSL port. So, because these are mostly used for external access, and likely that they will be opened and allowed the things. So, one such tool is Nmap, other is HPing and wget, right. So, these are the three popular, there are several others tools, and it is sometimes someone can write their own tool and type of things, but they are using the probe. So, external probe originating from a system outside EC2 and has an EC2 instance as the destination. So, that can be the external, and internal originates from EC2 instance and has destination another EC2 instance, right. So, this is internal and external thing. So, given external IP, DNS resolution query are used to determine external name and internal IP address, right. So, this is by the DNS query. So, survey public server on EC2, because to have a, if we survey goal to enable identification of instant type and availability zone of one or more potential targets, right. So, our the primary goal of this particular work is to whether I can basically identify the instant type and availability zone of one or more potential targets, that is one of the major thing. EC2 public IPs are in these prefixes, like, and there are public IPs of those tune as reported by the particular article, use external probes to find the responsive IPs, right, which are responsive, perform TCP connect probe on port 80 and followed by wget port at port 80 and perform TCP scan at port 43, and then they see that what are the IPs which responses. So, use DNS lookup, translate each public IP that correspond to either port 80 or port 43 to an internal EC2 address, and then do again the probing on the things. So, some 14,000 odd unique internal IPs are obtained. Now, this next is the instance placement parameters, right. What parameter you need to say that the things. Now, EC2's internal address space is cleanly partitioned between between the availability zone, right. They are partitioned into thing 3 availability zone, 5 instance type of instance type and zone as we have seen, 20 instance launch for each of the Fintan, what the experimental things they have done, and they have shown that samples from each of the zone are assigned IP address from disjoint portion of the observed internal IP address spaces, right. Assumption internal IP address are statically assigned to physical machines to ease out IP routing, otherwise it will again routing parameters will be there. Availability zone are use physical infrastructure. So, these are the things which are there. So, in other sense what we try holistically see that these are the different zones and different type of instances, they are on different IP block. In other sense, if I somehow select the same zone and etc., whom I am targeting, it is likely I may be in the same IP block. If I know that in the same IP block, then whether it is possible to launch again some of the probes and some of the attacks with the same IP blocks, right. So, what they experimentally they shown that 100 instances has been launched in zone 3 using 2 different account A and B 39 hours after terminating the account instance A, and of 100 zone 3 92 has a unique /24 prefixes, 4 prefixes has 2 instances each. So, these are their resultant. Out of 100 B zone 3 instances 80 are unique and 6 this. A single /24 had both M1 large and M1 extra large instance. Of 100 accounts of B's IPs, 50 were repeats of IP address assigned to the instance of the account A. That is interesting, right. So, out of that assigned thing which are A and B, so what they are launched in different time scale like A, and after terminating 39 hours of B. So, I got that address etc. So, if you look at it gives some sort of it tries to give in some maybe very grossly some cartography of, or in other sense that the IP address blocks and etc., how they are spread and so on and so forth. Now, if I have this type of things like roughly know that these are the IP address blocks and type of things are there, then whether determining co-residency can help or what can be done. So, network based co-residency checks instances likely to be co-residence if they are matching DOM 0 IP address, that as you have seen that domain 0 is that primarily do the management part. Small packet round out trips, if I have a round trip times, so that will be the small packet if in the same block. Numerically close IP range, typically within 7. So, that is another things what we are having. So, verifying co-residency is check is another challenge, that if 2 under self control instances are successfully transmitted by a covert channel, they are co-residents and so on and so forth. If you can connect them. Experiment the hard disk based covert channels they have shown. So, 3 M1 small account control victim probe what they did, determine DOM 0 address for each, each pair of AB. So, what they try to do that what is checking the co-residency of that two VMs and type of things. So, effective coresistence check for checking coresistence with the target instances, compare internal IP address to see if they are closer. So, if it is within the typical 7 thing, then it is a closer. If yes, perform TCP sync trace route to open port to the target and see if there is only one single hop DOM0 IP. Check requires sending at most 2 TCP sync packets, no full TCP connection is established. Very quiet check, little communication with the victim. So, these are the checks which are done some sort of a quote unquote non-invasive manner. That means the victims is not aware of the things. So, you are basically cross checking that whether it is some co-residency thing. And the third thing is causing co-residency. Two strategies to achieve good coverage co-residence with a good functions target. One is brute force placement. You want to do some brute force placement of the things by run numerous probe instances and find out that where things are there and you do a brute force. Other is target recently launched instances, take advantage of the tendency of EC2 to assign fresh instances to more small set of machines. So, if it is a after studying etc., that is it can be things that the service provider are doing, that is that close which are very instances launched in the within a particular small time span are placed into the thing into the same type of hardware or server, then there is a chance of doing a target recently launched instances and try to co-resident. So, leveraging placement of locality, one is that placement of locality instances launch simultaneously from the same account, do not run on the same physical machine. Sequential placement locality existing when two instances run sequentially, right, as we have seen that previously A and B. Parallel placement locality exists when two instances run at roughly the same time are often assigned to the same machine. So, these are the things which can be exploited, and there is a other way is that instance flooding, launch lots of parallel instances in the appropriate availability zone and appropriate type and try to see that what they happen. Similarly, they did a lot of experimentation to see that how this locality can be exploited. And finally, exploiting co-residence, that is cause-VM attacks can allow information leakage. How can we exploit shared infrastructure is one, that is means if I am co-resident, then how to exploit this, like gain information about the source uses of the other instances, create and use covert channels to intentionally leak information from one instance to other. So, these are the other things which can be exploited by the attacker. Some application of these covert channels are co-residence detection, whether it is the thing, there is whether I can have some secret detection scheme to look at it, whether timing of the keystroke allow me to look at the password and so forth. And other type of techniques which are there in other cases, other this type of covert channel attacks is one is that measuring the cache uses that and trying to see that what is the normal pattern and whether there is a any attacks etc. there, and try to map that what sort of processes are there based on the cache uses pattern. So, one is that exploit load based co-residence checking, that exploiting co-residency. So, co-residence check can be done without network based network or adversary, because I am co-resident. So, I do not require again now the resident because other network infrastructure I am on the same machine. So, here they have shown this with the experiment that the trial 1 and 2 were co-resident on distinct physical machine, instant 3 were not co-resident. So, that what if you look go through the paper this has been shown, and it has been shown that estimation traffic rates, that what sort of traffics are there with no HTTP, with HTTP connection and so forth. These are the figures and data taken from that particular research article. And other things are keystroke timing attacks, right. So, based on the keystroke, and this is a very popular or very well known type of things. Based on that, whether you can basically look at that passwords and guess the password and try type of things. So, finally, that whether the what type of preventive measures we can think of. One is the mapping, use randomized scheme to allocate IP address, block some tools like Nmap and traceroute. So, blocking tools may be okay, but randomized allocation may basically may be going against in some cases that the optimization or resource management of the things, right. So, what they are the from the perspective of the service provider. So, that may be a challenge. So, core resistance check prevent identification of the DOM 0, that may be one of the way. So, what of that, so that they cannot check that what is the domain 0. Co-location not allow co-residence at all, right. So, that means beneficial for cloud user, but not efficient, definitely not efficient for the cloud provider, and information leakage via side channel still is a big challenge, like different type of side channel things are there, and it is not only that you create a covert path like that, you basically judge different other parameters to look at, like maybe the, as we are looking at that, the looking at the cache behavior or the how the cache uses pattern. I am trying to look at that what sort of activities are going on. So, with this we end our talk today, that new risk from the summary of that security thing, that new risk from cloud computing there, which is little different from our conventional computer or information or network security. Shared physical infrastructure may and most likely will cause problems. Exploiting software vulnerabilities are not addressed properly here. Practical, we have not, there may be some software vulnerability if that the SaaS level cloud and etc., which have not been addressed. Practical attacks are in that particular paper, they have shown that particular attacks are performed, and sound countermeasures are also proposed in this work. So, I encourage you to go through this paper, so that it is a good, again I am repeating, it is not to particularly look into particular service provider or look at their loopholes etc. More things we want to see, look at a overview that these are the things possible, or these are the things which open up new risk etc., which are not there in our traditional network or computer or information security. So, with this we will end our talk today. Thank you.